Okay, this is class notes E in lesson 1. So for this problem, I'm going to illustrate how we solve a non-homogeneous first order linear differential equation. And this is going to be an illustration, let me scroll up a little bit here, of the process that is described down here. So if we are solving a non-homogeneous ODE, the first thing we should do is find that integrating factor and then try to go through the steps involved in solving for y. I will qualify what I said just a few seconds ago, that the first step being we should find the integrating factor. I will show you in the example after this one in class notes F that sometimes that might lead you awry, right? So, but I don't want to spoil the fun in that example. So for now, I'm going to say, great, let's find the integrating factor. So let's figure out what our a of t function is here. So a of t is 1 over t. And then what's the integrating factor? So the integrating factor, mu of t, is the exponential of the antiderivative of a of t. Great. So we know what a of t is. It's 1 over t. And the antiderivative of that is ln of the absolute value of t. There is a plus c here technically, but what's going to happen, right? What's going to happen is that e to the c is going to turn into k. And that's going to be the famous little k that we talked about in the previous class notes that I mentioned, going back up here, right here, it's still left over, that I mentioned we don't need that k. We don't need to carry it around, right? We can choose k equals 1. And because we're multiplying the ODE through by mu, choosing k equals 1 or any other k value that's non-zero will do the job in terms of what mu is supposed to do. So all of that is to say that, again, we are not going to worry about k, which in this context of calculating mu means that for once, a mathematician is telling you, do not worry about the plus c in the antiderivative. All right, so we're going to not worry about this plus c there and finish the rest of the calculation. So e to the ln of t, e and ln are inverse functions. So I just get t from this. And then I am going in and saying, great, so I know my a of t. So a of t is t. And then what do I do? So the next step in the process, and I'm going to illustrate the whole process rather than going back and using the formulas and just plugging in everything. So I'm going to say, all right, step number 1 in the whole mu of t process was I would multiply the entire ODE by mu. So mu in this case is t. Great. So I multiply that, and this means every term gets multiplied here by t, and I get this as my new ODE. And this is now a great time to check, right? The whole point of mu was that it was supposed to make the new left-hand side into a product rule. So I'm just going to write that out, product rule of mu, which in this case is t times y. So ty. So that is what mu was supposed to do. And I'm just going to do a quick little check here. This is useful to do to make sure that you've calculated your mu correctly. So is d by dt of ty equal to ty prime plus y? Well, let's do a quick little check. This is the derivative of t times y. So derivative of t is 1 times y plus the t times the derivative of y with respect to t. So there I'm using the product rule from calculus. And is this equal to ty prime plus y? Well, that's ty prime, that's ty prime, great. Plus y. So yes, great. So we did our check. Again, that's useful to do to make sure that you've done the mu integration correctly. So now we are proceeding very well here. And to finish solving this ODE, we're going to go back here. And this is exactly the situation we want to be in. We have the derivative of something equals some function of t. Great. So we're just going to integrate both sides. So I get t times y of t equals antiderivative of t cubed dt, which is t to the 4th over 4 plus rc. So we have ty of t equals t to the 4th over 4 plus c. By the way, these three little triangular dots mean therefore, shorthand for therefore. And now we are going to solve for y of t. So we get y of t equals dividing by t cubed over 4 plus c over t. Great, so this is the solution for y of t. And we want to go back up to this problem, the problem statement, and double check. Always a good idea to make sure that there are no initial conditions provided. So there's nothing here to give us an initial condition. And it's nice that the problem tells us that t is positive, right, in terms of the domain of the function y of t that we were trying to solve for. Nice, because what we end up getting involves a t in the denominator, right? So we want to make sure that t is never 0, which it's not on that domain. So this is the solution that we get, and that is the end of our class notes.